Jai Hind everyone. Welcome to the lecture series on cloud computing. Subject code is KCS 713. Myself Rekha Baghel, Assistant Professor, Computer Science and Engineering Department, Akgec Garg Engineering College, Ghaziabad. Today's topic is map reduce. So this is the outline of the this lecture. First, I will discuss about the map reduce and the main need of the map reduce, and after that the challenges faced by the cluster computing will be discussed. Map reduce fundamentals, example code and workflows, and in the last I will conclude the topic. So basically, if we talk about the internet used by the users in these world, so there are almost 10 billion web pages, and average size of web page is 20 KB. And if we calculate the total size of these web pages, it is almost 200 terabytes, and the disk read bandwidth required is almost 50 MB per second. And if we calculate the total time to read, it is almost 4 million seconds, or in summarization form we can say it is needed almost 46 plus days for reading. So if we need some data analytics to apply on these web pages, it will require more days. So how we can reduce these days? So if we are reading we just read all these pages, it needs almost 46 plus days, and if we apply some data analytics, it needs more days. So what is the solution of this? How we can reduce this time schedule? So we can use the multiple systems to store these data and apply the parallel processing. So the solution is, there is a big data, and this big data means, here we are saying that this is the big data which store all these web pages, and the solution is we can split this big data into small chunks. So we separate this data into the small chunks and store these chunks into individual systems, and these systems process the small chunks, and at the last we collect the results from different machines, and we summarize, or we can combine all the results produced by the different machines. So this is the solution. So solution is distributed data processing in cluster of computers. The whole scenario is known as the distributed cluster computing. So distributed computing can solve the problem of how we can process the data, but there are some challenges which can be occurred using this cluster computing. So cluster computing, the main challenges of the cluster computing is, challenge number one is we are storing the data in different machines, and if one machine, so here we are saying one machine as a node. Node is a term that is used to express one machine. So node failure means, if we are storing the data into the machines, and these machines are basically a servers, we consider it as a servers. So we are storing the data into the machines, and it's a server. The lifetime of a server can be calculated like it is of 1000 days. And if we talk about the clusters, so cluster can have 1000 servers, or we can maximize the capacity of a cluster. So we can consider it can have 1 million servers in a clusters. So we assume that if it is having 1000 servers in a cluster, so in a day one failure can occur, means one system can stop working, and if it is having 1 million servers in a cluster, then the rate of failures high, it is almost around 1000 failures per day. So if consequences of node failure, so we are saying that in a day, if it is a 1 million servers in a cluster and it is the failure rate is 1000 failures, means 1000 servers failed in a day. So the data stored at these servers might be lost. So the main challenge is data loss. And second one is node failure in the middle of long and expensive computations. If we are performing some computation and suddenly the server at which the data is stored is stopped working, that means the computation that is going on particular server is stopped, or we need to restart the computation from scratch. So this is the challenge one. Second challenge is network bottleneck. Network bottleneck means computers exchange the data in a network, and so it required the high bandwidth. Typically the network bandwidth is 1 Gbps, and moving 10 TB of data takes 1 day. If we are moving the data of 10 TB from one computer to the another computer, it takes around 1 day. So it is a challenge for cloud computing. So a third challenge is distributed programming is hard. Why I am saying this? Because data distribution across machines is non-trivial. Means suppose we are performing some processing on the different machines, and these machines have suppose P1, P2 and P3. These are the different processes, and these are runs on different machines. Suppose P1 is run on this M1 machine, and P2 process is running on M2 machines, and P3 process is running on M3 machines. So if these processes are interconnected, means there is some order that need to be arranged so that the result will be accurate. So if the P1, the order is comes in the existence using race conditions. So if the order of the execution of the processes is matters, that means we need to apply the we need to avoid the race conditions so that this order will be maintained. This order will be maintained, means P1 must be when the results of all these processes will be combined, then if the sequence of the processes must be P1, after that P2, after that P3. So when the results of all these three processes will be combined, the order of these processes will not be changed. Using this, we can avoid the race conditions. So avoiding the race conditions is quietly difficult in distributed programming. So this is the given two tasks, T1 and T2, and correctness of results depends on the sequence of execution of task. For example, T1 before T2 is must, but not T2 before T1. So as I already told, so these are the three processes, P1, P2, P3, and the execution of results will be in sequence. Like first P1 will be executed, then P2, then P3. So what is the solution of all these three challenges? The solution of all these three challenges is MapReduce. So MapReduce is basically it is a programming model for processing the big data, or providing the parallel processing of the big data. So it is use the cluster of computers. So MapReduce, as the name of the MapReduce expresses like map plus reduce. So basically we can consider one example. So in MapReduce we have a input. We have a input, and this input is of type text. So this is of type text, and this input can can be of any size, like it can be of KB and MB, TB, means size does not matter. We can have high data size or low data size. So the map reduce basically get a input and converts the input into the list of words and their occurrences. Map reduce basically works in key value fashion. Key value fashion means here we have a words and here we have a frequency of the words occurred in particular text. So in this map reduce, we ignore the capitalization and punctuation. We don't consider these terms. So we can have one example, like suppose we have an example like this is a text, the person went to the store. The person went to the store. This is a sentence and we need to process it using the map reduce. So in map reduce, first we have to identify the words in the sentence. So here we there are the different words like the, person, went to, and store. So these are the words that are that exist in the this sentence. So next there is key value pair, means these are the keys and we will find out the values of these keys. So the is a key which occurred there two times in this sentence, the and the. So we write two here. Person, the occurrence of the person is 1, so we write here 1. Went is occurring one time, so we write here 1. 2 comma 1, 2 is frequency of 2 is 1 and store is 1. So there are the so we write here the frequency along with the words. So map reducer, so we can say that mappers with these are the two components, mappers and reducers. So map basically read the data from the input is of file system and output the modified data. The task of reducer is to collect all the mappers output on the keys and output reduced data. So here the output data is written to the disk and all data is in terms of key value pair. So in map reduce framework, the output is only in the form of key comma values. So key is the words and value are the frequency of the words. So major components of map reduce is, the major components are mapper. First is mapper, second one is reducer, third one is combiner and fourth one is partitioner or shuffle. These are the four components of the map reduce. So till now we have know that all the data in map reduce is in the form of text or it is in the form of key value pairs. Key is any word and pair value is the frequency of that word, and it is of arbitrary type. Data is read from the file or list of files from the SDFS, Hadoop distributed file system, and the first we will splitted this data with the help of splitter, and this chunk means there is a name node, means this data is divided into different chunks. Each chunk is of 64 MB and 64 MB more or less can be configured depending on your use. 64 MB, 64 MB, 64 MB. Generally we have a 128 MB, we consider it 128 if we are working in big data. So the chunks is of type like 128 MB. So after that splitting the data, next is mapper. The mapper read the data stored in these machines, and after that mapper emits a set of data typically derived from its input. In after that the task of reducer came into the existence. So reducer reduces the data provided by the mappers. Now reducer, before reducer works, the shuffler, there is a in between component, that is a shuffler, who shuffles the ordering of the key values. So reducer receives each key of data along with all of the values associated with it, and always be sent to the same reducer. So reducer emit a set of data typically reduced from its input, which is written to the disk. So this is the data flow of the map reduce. First we have a input. This input is taken from the data disk or some file or some SDFS, distributed file system. We take this input from SDFS. The first task is done by splitter. So task of splitter is to divide the input into the different chunks, like split 0, split 1 and split 2. We split the data into different chunks. After that we apply the mapper to each chunk. Means mapper 0 will apply to the split 0, mapper 1 is applied to the split 1, and mapper 2 is applied to the split 2. After that we apply the mapper, we reduces this using the reducer, and finally the output is produced. So input splitter, here we apply this splitter. So input splitter, it is responsible for splitting the input into the multiple chunks, and these inputs are worked as a input to the mapper, and the splitters, the default size of the chunk is 64 MB, and this size can be expand depending on the need, and the splitter can be used one for means this typically you can use just one of the built-in splitter unless you are reading the specially formatted file. You can have multiple splitter or a single splitter depending on your need. So mapper, the working of mapper is, this mapper reads the input data which is in the form of value. This is K is the key and V is the value, and outputs the data in the form of pair K dash V dash, means here combine, we are combining the results. So suppose we can take an example, like the example is the teacher went to the store was closed. The store opens in the morning. The store opens at 9 a.m. This is the whole text, and we need to process this text with the help of MapReduce algorithm. So first, when we see this whole paragraph, we will apply the splitters. So the task of splitter is to assign the word with its frequency. So now we will start from here. So we write here and frequency is 1. Next teacher frequency is 1, means it is occurring here one time. So next went, then along with its frequency 2 and 1, and 1, store, 1. So initially we write the words with their frequency. He initially we did not consider how many times it is occurring. We count the words one by one. So here the again comes, but this is the and we write it here, one store, one was. So whole sentence is processed similarly. So this is the step of splitter. So this is the task of splitter. Now reducer. So reducer, the task of reducer is to reduce the data, reduce the key value pair. So here you are seeing that here the is here and the is here, and again the is here. So we reduces the occurrence of these words. How we can reduce this occurrence? By using the reducer. So reducer accept the mapper output and collect values on the key. All inputs with the same key must go to the same reducer. So here, so we can see here we calculate the occurrence of the and write the frequency of that particular word in the value pair. So here the frequency of the is 6. So we write it here 6. Teacher is occurring one time. Went is occurring one time. To is occurring one time. Store is occurring 3 times. Means store is here. This is the first occurrence. This is the second occurrence, and this is the third occurrence. So we 1 1 1. So we combine it using 3. Was is one time, closed is one time, open, morning, at and 9 am. All these words are occurring one time. So the output after applying the reducer, the output is in the form of this. So reducer. So next is combiner. So combiner is at this moment we have a separate output produces by the reducer. Means the output are in the form of the, comma 1, teacher, comma 1, went, comma 1. So output in this form. This is the output produced by the first reducer. This is the second. This is the third. And the task of combiner is to combine all the outputs produces by these reducers. So combiner is a intermediate reducer. It is optional. Reduces output from each mapper, reducing bandwidth and sorting. Cannot change the type of its output. Input type must be same as output type. Output committer. So the task of output committer is this is to taking the reduced output and committing it to a file. So the committer needs a corresponding input splitter. So usually the built-in splitters are good enough unless you need a output to a special kind of file. Partitioner or shuffler, it is a the partitioner or shuffler decides which pair are sent to which reducer. So here the task of shuffler is to which pair went to the which reducer. Means here this split is given is assigned to the reducer 1, this is assigned to reducer 2. So which split is assigned to which reducer? It is the task of combiner or shuffler. So partitioner or shuffler. So default is it is assigned by using this code, key dot hash code, mod number of reducers. So user can override to provide more uniform distribution of load between reducers, some value might need to be sent to the same reducer, and it is a binning of results. So, there are the basically two types of nodes, or we can say systems. First is master system and second one is slave systems, or the master system. The responsibility of master systems is to schedule and managing the jobs. The scheduling master schedule the computation should be close to the data if possible. Bandwidth is expensive. First, the data is to which system this data is stored is decided by the master computer. So, it assigned the data, or it is stored the data to the nearby system to its location, so that the if query, if it get any query related to particular data, it search out the data from the nearby systems. So, it is the task of the master system to store the data into the nearby systems. So, it relies on distributed file system. If a task fails to report progress or crashes, the machine goes down, it assumed to be stuck, and it kills, and the step is relaunched. So, one important point is when the master storing the data to some particular device or machines, it basically store that particular chunk of data to the at least 3 systems. Means if it is a chunk of data C1, and master will store this data into the 3 devices at a time, means machine 1, machine 2 and machine 3. The reason behind the application of this data is that if the data from one machine is lost due to some reason, the data must be available to the other machines. So, data availability is assured by the master. So, the master handles by the framework, no user code is necessary. So, this is the basic data flow. Here we give the input, the data is fetched. After that, data is processed by the different mappers, and finally we merge the output, and combined output is given to the user. This is the handling data by the different mappers. So, map reduce algorithms provide a simple way to scale the applications, or it provides the fast processing method to process the big data. So, it scale out to more machines rather than scaling up. Next one is if it is scale from single machine to the thousands of machines. Fault tolerance and high performance is provided by storing the data into the at least 3 machines, and data availability is assured by the map reduce. And if you can fit your use case to its paradigm, scaling is handled by the framework. So, map reduce algorithm is very important in terms of big data. In today's work, when we have a large amount of big data produces by the different social networking sites and different audio video websites. So, the processing of this data can be done in fastly manner by using the map reduce algorithms. Thank you.